Okay, thank you for the introduction, and thank you for proposing me to provide this talk. Abital is actually an intensive therapy dedicated to children with cerebral palsy. We all know here that CP is the first cause of motor disability in children, and depending on the location and the extent of the cortical lesion, we can have different type of CP. However, whatever the type of CP, we all know that to date we only have a few efficient treatments. So we'll come back to this figure that you have probably not seen during this Congress. But it is important because in the green bubbles of this study of Iona Novak, all these interventions that she pointed as efficient actually have common ingredients that were highlighted yesterday by Rosalind Boyd. Intensity is one, shaping, gradual increase in difficulties another, functional goals that are set by the child and the parents is another, motivation that is driven by the fact that they work on their goals, but also by fun, by the fact that the environment is really child-friendly is important. And finally, these interventions are hands-off. It means it's voluntary control, voluntary movement. It's not guided by the therapist. So she went further in the description in a second paper of what was useful for different type of CP. And so she first focused on children with unilateral cerebral palsy. And if we check what is useful and effective for children, for child active rehabilitation, you can see that while there were at that time some intervention for whole person, some intervention for arms, something was missing for lower extremity. That's why back in 2010, I went to Andy Gordon's lab and I told him, well, I would like to develop an intensive intervention like your HABIT, so a bimanual intensive intervention, but with a constant stimulation of lower extremity and posture. And he told me, well, Yannick, you know, I think this is not gonna work. I said, yeah, maybe, but I'll still do it. And he replied, then I will support you. And that's what he did. Actually, he supported me to build this intervention, and thanks to his support, I'm here today. So thanks a lot, Andy. What did we do together? So we designed this Abital program. That is a program of 2 weeks of intervention, so 90 hours over 2 weeks, so it's 9 hours a day for children with unilateral cerebral palsy. And it's a constant bimanual and lower extremity stimulation. So it's not sometimes upper extremity and sometimes lower extremity, is constantly both together. And the first study focused on children older than 6 years old. You have a few pictures here of the intervention. And in this first study, that was a randomized trial, we could show that there were effects on upper extremity and on lower extremities. So upper extremities are represented here. And you see there is the assisting hand assessment and the Abital kits. And you've got two groups of children. One who came first for 90 hours of intensive intervention over 2 weeks, and then was followed for 90 hours of regular intervention over 4.5 to 5 months in mean. And the other group did the opposite. We followed them first for 90 hours of regular intervention, and then they came to a camp for 2 weeks, 90 hours of intensive intervention. What we can see is improvements during intensive phases where children are totally stable during conventional intervention phases. That's true for upper extremity, but it was also true for lower extremity. So with the 6-minute walking test, we could see an increase during intensive phases in endurance And with the Abital questionnaire, we could see an increase in locomotor abilities of these children. We even go further afterwards with one of my PhD students to study the coordination of upper and lower extremity, and that's something you can see on the poster of Daniela Ebner, who works specifically on that in my team. Finally, that was a surprise, we had effect on social participation. So with the life habit, we could measure increase during intensive phases. These increase corresponds in the daily life of children to children starting, for instance, to make bicycle with friends in the neighborhood, or children going to the Scouts, which is very popular in Belgium. There was a question remaining. It was working, okay, but it might be that this lower extremity component was kind of preventing to have the full change we could have if we were only focused on upper extremity. So still with Andy Gordon, we compared a regular treatment with HABIT, just bimanual, with HABIT-ILE, bimanual and locomotor. That's a study that was done by Geoffroy Saucé, was one of my PhD students, and he showed that yesterday, the full results, we had absolutely no difference for upper extremity between just bimanual or bimanual and locomotor treatments. That is true for Abital kids and the assisting hand assessment that were our primary measures. So all these changes are likely due to neuroplastic changes in the brain. And that's something I have had the pleasure to investigate with Kathleen Friel of Burke Cornell. So with TMS, we investigated which were the cortical area that were controlling the paretic upper extremity. So here you can see in a child, we are before treatment, and a red dot means that this part controls the first dorsal interosseous, so the fact to do this movement, and a blue dot means a control of the wrist flexure. Purple means area controlling both. With the same level of stimulation, after 2 weeks of HABIT-ILE, we found this in that child. So you can see that the amount of dots that are in color is twice larger. So the cortical area controlling the paretic hand has largely increased. Of course, it's a good example, but if we check what happens in 16 children, you can see that this is significant for all children, both for the digits and for the wrist. So neuroplastic changes, let's say roughly of gray matter, we could also investigate that with fMRI, but I'm not going to show you the results today because I have not enough time. We wonder whether these gray matter changes were also associated to changes in white matter, especially the corticospinal tract that allows to connect the part of brain that control limbs and actually the limbs could be changed during intensive intervention. That's why we investigated with diffusion imaging in 48 children what was happening. So 26 children were tested with diffusion before and after intensive intervention, and 22, the control group, were scanned with MRI, with diffusion tensor imaging 2 times without intensive intervention in between. And we could show that actually the anisotropy, so it's a measure of quality of the corticospinal tract, increased after intensive intervention. And this increase in the quality of the corticospinal tract, it was directly related to the change we observed in dexterity. So there was a correlation between the change in dexterity and the change in the quality of the fibers. Why is that? Well, we think that this is linked to the fact that the process of HABIT-ILE including gradually increasing difficult tasks, induce a myelin synthesis by the oligodendrocytes. Why do we think that? Because animal studies show that if you take some rats and you take the same rats, you make two groups, and one group of rats has to run in a normal wheel, and the other group of rats run also in a wheel, but you make the wheel more and more complex. You have steps of different size and things like that. This group of rats that is faced with more and more complex tasks for the same amount of exercise will have an increase in the anisotropy of the white matter pathways, while the other group will not. So it seems really that it's the gradual increase in complexity that induces this increase in the quality of the tracts through a process of myelination. So all this was about children with unilateral cerebral palsy. So these were nice results and we were very happy, but actually 65 to 70% of children with cerebral palsy do actually have a bilateral cerebral palsy. And if we go back to Novak in 2014 and we check child active rehabilitation for children with bilateral cerebral palsy, we can see that there is nothing for arm and nothing for legs. So, of course, we decided to try to translate our HABIT-ILE for children with bilateral cerebral palsy. Again, the same team. We say that we don't change a team that works so well. In UC Louvain and Columbia, we ran a study with 20 children with bilateral CP. They were mainly GMFCS3, although we had a few GMFCS2 and a few GMFCS4. These are the results we obtained with these children. So here you've got the PEDI, it's a self-care subscale, the Jepson-Taylor test of hand function, the gross motor function measure, and the 6-minute walking test. What you can see generally is that the group in black, the group who received the Abital treatment, improved a lot during intervention and continue improving or maintain the results at 3 months, while the controls were systematically stable over time. They were measured at the same time points, so 2 weeks apart and at 3 months follow-up, but without intensive intervention. And this is systematically the same, so it increased. Here it decreased, but Jepsen is measuring time, so less seconds is actually better. The percent in GMFM also increased a lot, and the 6-minute walking test too. And finally, their personal goals increased a lot during that time and were maintained at 3 months, although the goals may be different. So at that point, that was very nice because it could be translated to these children, but we were very surprised that many parents, both for children with bilateral and with unilateral cerebral palsy, came to us after and said, "This is very good, the goals, you can do that and that, but it's so much better for school." What? For school? Really? We didn't train anything for school? And then it was Rodrigo Araneda, who works as postdoc in my team, that said, but maybe we are changing things at a higher level. Maybe this very intensive training has an effect on executive functions. And so we started measuring executive function with 2 tasks, a strobe task that you can see here, and a flanker task that you can see there. Globally, children had to respond to different stimulus by pressing buttons, and we made sure that buttons were accessible for everyone. And what did we observe in both tasks is that you have the results here. So you have here a group of typically developing children of the same age, totally matched age and gender. And you've got a group our group of 28 children with CP at the start of an intensive rehabilitation intervention. So you can see there is a significant difference. So we have a slower reaction time for the children with CP. This is not related to the movements, because in this task, we do have congruent and incongruent trials, and so we are making the difference between the two to avoid to have the movement being involved, okay? So this is before intensive intervention, and this is after intensive intervention. You can see it's significantly different, but also it is no more different from typically developing children of the same age. And the same is observed for the flanker task. So we really think that there is a major effect on executive function of intensive interventions. If it has a major effect on executive function and on motor function, then why wouldn't we go to younger children? Because we know that theoretically they are more plastic. So that's what we decided to do last year. We decided to adapt HABIT-ILE to early HABIT-ILE children between 1 and 4 years old. The same principles were used, but we had to adapt schedules, material, and also the contact with the parent, which is very different from older children. So this pilot study was run in Brussels in March 2018 with 10 children with unilateral cerebral palsy. It was 5 hours a day over 2 weeks. And so children came from 9 to 12, then had a nap with their parents, and came back from 2:30 to 4:30 for a total of 50 hours. A few pictures. Oops, I have a problem. Okay, the results showed, so this is the AHA, this is the Melbourne for both hands, and the COPM and the GMFM. So what does it show? We had a baseline of, so we assessed the children 2 times over 2 weeks, okay? And then after intervention, and then at 3 months. So we had an important improvement during intervention that was maintained for the AHA at 3 months. And the same for the Melbourne, for the more affected hand, but also for the less affected hand that improved. The COPM showed a huge improvement maintained at 3 months, and the gross motor function improved also. So these results were more than encouraging, and then we applied to the Fondation Paralysie Cérébrale with a European consortium to have a large funding to run a randomized trial for children with 1 to 4 years old. And we were very happy to be successful, and so we are running now this large study where we measure the functional changes, the neuroplastic changes, and the biomechanic changes of a group of 100 children participating in this large project. We also have the chance to have an animal model that will help us to really understand what's going on deeply in the neurophysiology of the brain. Other projects running are actually, we are trying now to see if or whether HABIT-ILE can be translated with a virtual tool that we help to design in order to help implementing this in institution or for children who are living far away from physio. That's something that is run by Geoffroy Saucé in my team. And also we have 3 multi-site randomized trials for children with bilateral CP, currently running 2 with Columbia and Burke, and a large trial that just started in Australia. Finally, we also try to apply these kind of programs in Africa, and notably in Benin, with my PhD student Emmanuel Sogbossi. You can see also his posters during the poster session, because we really think that this kind of intervention matches what is needed in developing countries where there are very few centers and people are living far away from these centers. So I would like to thank all the people who contributed to this work, especially my wonderful team, and also, of course, my friend Andy for his support from the start of this work. I will now go to the conclusion. I was afraid to be too short, so I put the conclusion at the end in case I was skipped. So the keys for HABIT-ILE is that this intervention is intensive, functional, based on motor skill learning, and is a child-friendly intervention. It can be adapted to different ages and environments, and we saw that the dosage can also be different for young children, and it still works. This intensive intervention can be applied in upper extremity, but as you saw, also concomitantly in upper and lower extremities. And we can drive changes in upper and lower extremities of children with unilateral and also bilateral CP. There are neuroplastic changes associated, and this opens many new questions and perspectives. What about dosage? What about optimal age? What about the effect of repetitive interventions? So there's many more things to investigate in the future. So thanks also to all the foundation that helped to fund all this work. Thanks a lot. Merci.